Right, morning everyone. I want to have another go at this impacts of fishing lecture, and I thought this would be a good way to provide it. So I was talking about the impacts of fishing, and I want to go through a story that's a big story in fisheries, and it may not be entirely an impact of fishing, but a lot of people think it is, and I think it's one of those fisheries where there's a sort of 50-50 sort of blame, really. Sort of partly it's industry and partly it's changes in the environment. And the combination of two, and it's quite frequent, you see this in fisheries, that we don't act quickly enough to change the direction of a fishery. So when a fishery starts going down, it takes a while for managers to get a hold of that and sort of turn it around again. If we reacted more quickly, then perhaps we wouldn't see disasters like the Grand Banks disaster that we saw. And then I'm going to sort of try and, so that leads quite nicely into sort of discussion about fishing disturbance and environmental disturbance and how both of these have a role to play in changes in the marine environment. And we'll talk about physical impacts, about how those how trawling in particular, but we're going to talk mostly about trawling because that's the big one, and Andy's going to talk about potting later on, and he's already discussed other static gear methods. And we'll talk about proximate ecological impacts. Those are sort of immediately obvious ecological impacts of fishing, and that's things like when the sediment on the seabed is stirred up. And then we'll talk about kind of more ecological, it's not quite proximate impacts, it's slightly the secondary impacts. So the seabed is disturbed, and what does that mean for the organisms that live in and on the seabed when they're impacted by trawling? And then I've sort of thrown in this bit at the end, because one of the things we'll talk about is spatial data in trawling, and I want to show you how you represent that data can tell a very different story. And those, a bit like the example I gave you of mackerel, where scientists from Norway and scientists from Iceland had looked at the distribution of mackerel, and depending on the story they wanted to tell, they gave a very different distribution. So the Grand Banks fishery, east coast of the States and Canada, so basically on the border there. It was very, very important fishery, massively important part of Spanish culture and UK culture and boats. Way back when we were sailing boats rather than engine-powered boats, were sailing across to George's Bank. And you'd have these big motherships that would have lots of rowing boats on them, basically, and they would put people over the side in these rowing boats in the middle of the sort of northwest Atlantic. And they would fish for a day and then come back to the boat, and then on the boat they would salt the fish so they could be preserved. And that salt fish became part of quite an important part of culture, both positively and negatively. I mean, salt fish was used to feed slaves. At one point, there was this nice sort of, not nice, but there was a triangular sort of trade route, which was, I think Martin mentioned this during his review of the history of fishing, where you had salt fish going down to the Caribbean to feed slaves, and then the produce of the Caribbean being exported across to the UK, and then the coming from the UK back across to George's Bank. So, it's an important part of our culture. But basically, this was a very, very successful fishery, and it was producing hundreds of thousands of tons of fish. Most of the fish that was being caught was cod, which is a gadoid, Gadus moria, and they were also catching 25% dogfish. They weren't really interested in dogfish. You'll see that advertised in fish and chip shops sometimes as rock salmon. It's basically a small shark. But they weren't interested in that at the time. They were mostly interested in cod. In the 70s, there were some big political changes that were caused in part by the States and in part by the UK impinging on Icelandic fishing grounds. And both the States and I think it was Iceland that started it, and they said, right, we're going to implement a 200-mile exclusion zone around our country, and we don't want anybody else to come inside there without our permission. And then the whole world agreed to the same thing. And so now every country in the world has a 200-mile economic exclusion zone, except the UK, where we're opposite Holland and France and things. It's halfway across the North Sea. So 1977, there's 825 boats, 14,000 people employed by the industry. That increases in 1980 to 14,000 boats and 33,000 people. So it was a fishery that increased in the 1980s. But by the 1980s, the ratio of fish being caught was 15% gadoid and 75% dogfish. And dogfish survive being captured because, unlike cod, they don't have a swim bladder. So quite often the survival rate of gadoids is much higher than dogfish. But then there was a bit of the fishery didn't continue, and what happened was in the 90s, so there was a big impact and big increase in the 1980s, the landings of cod by Canada from the FishStatJ database, which is freely available. It's an FAO database. If you just look up FishStatJ, and you can see there's a sort of plateau in fishing. So landings increased and increased and increased, and they stayed high. And they stayed high because there was this rapid change in number of boats. So because there were more boats, they were catching more fish. Or catching the same amount of fish. But then the fishery could no longer sustain things, and it collapsed over a couple of years. It's quite a complicated story because there was actually still a healthy fishery inshore of small cod around here. But the guys inshore were noticing changes. They noticed the size of the cod was getting smaller. On the guys on the wee boats inshore, and they mentioned this to the Canadian scientists. And the Canadian scientists just ignored them basically, and it turned out they were right. There was something going on with the fishery, and these small cod were being caught by the inshore fishery. They weren't being landed; they were just being caught and then discarded and thrown away. So they weren't actually doing anything for. They're probably supporting the dogfish population, but then the fishery just collapsed, even and with little warning, because cod are a shoaling species. So we're catching these species in shoals, and then it collapsed. In the 1990s, there was a moratorium on catching cod at all, and the landings became very, very, very much reduced. Some of these will be taken from places other than the Grand Bank by the Canadian fleet, but it didn't increase again. It's not recovered, even though there's no fishing going on at this point. I mean, the lack of landings isn't just population here; it's lack of fishing effort as well. But it was a disaster because if you remember, we talked about how important fishing is economically, and it's one fisherman at sea supports between 7 and 15 people ashore. And here, you had an industry that was dependent upon hundreds of thousands of tons of cod, collapsed down to tens of thousands, and there's a whole industry that lost out because of that, and whole families and industries. So it's the fishing inspectors, it's the engineers, it's the shops, it's the boat builders, it's the people that take the fish, the people that transport the fish elsewhere, the freezers, the salt suppliers, all the rest of it. All these people were put out of work. And I think it's a good parallel to say you think about mining in Yorkshire and how that massive change impacted on our culture and economy in the north of England. So, I mean, this is a map of the fishery. So it's, you can see there's a couple of key players in here. There's capelin. These were the food fish for polar cod, and a lot of other species as well, but cod were the commercial species. So capelin were eaten by cod, and then the cod were caught by fishing vessels. Now, one of the things that happened in this fishery, and one of the reasons why I said it's not just down to fishing, it was actually capelin basically disappeared at one point, and they think it was something to do with temperature. There was a decrease in temperature. The water temperature in the north west Atlantic plummeted, and they were finding shoals of frozen fish, basically. And given that capelin are sort of the main foodstuff of cod, the population couldn't be sustained. And there were reports of cod being caught straight out of the sea that resembled cod that had been kept in an aquarium and not fed for 2 or 3 months. So they were in a really bad way, and hence the collapse. And fishing vessels were still fishing for them. So the point I'm trying to make here is that there's a combination of effects. It's not just that the fishing decimated the population. That is part of the problem. They didn't control the fishing adequately in order to let the population recover again. But there was an environmental impact And this is a problem that's caused by the sort of lag between changes in the environment and fisheries management. It's something that we need to deal with. The fisheries is one of those things that has a big impact. There's a sort of link between the size of an impact and how long it takes for the environment to recover. So you see along the bottom here, this is a log scale. So this is a patch size. How big a scale does this activity take place over? And then how long it would take for an environment to recover. And this is a very big generalization, but if you look at fishing, which is up here, you can see that's regarded as a large-scale impact, and that if you stopped it tomorrow, it would take more than between 5 and 10 years for environments to recover. Big generalization. It depends where. It depends on what you're fishing for. And you see hydraulic dredging down here. Takes place over hundreds of square meters and takes between several months for recovery to happen. Right down in the bottom left-hand corner, you've got feeding activities by organisms that live in sediments and on sediments, and they're looking at the scale of tens of centimeters square, and their disturbance doesn't last as long. So the point is, fishing on a big scale can have an impact that takes a long time for the environment to recover from. And it's not just the size of the sort of spatial disturbance. It's also how the interaction with natural disturbance. Okay, so if you have an environment where there isn't much in the way of natural disturbance, so mud sediments, for example, mud only tends to exist in places where there's not a lot of water movement. It doesn't get washed around a lot. So at the bottom of estuaries, for example, where it's very slow water flow, is not very disturbed, and there's quite a lot of deposition of mud, you'll get an environment that isn't that disturbed. If you go somewhere like a seashore, just sublittoral on a shoreline, and basically what you can do here is you can compare the outside and the inside of Spurn Point. So the inside of Spurn Point is estuarine, muddy, smelly, and on the outside you've got lots of wave action, and that wave action means that you have a shoreline that's dominated by sand, and it's very mobile. And so fishing disturbance on that mobile sand on the outside of Spurn Point would be very limited in relation to the natural disturbance. So if you dragged a trawl along the seabed just offshore from Spurn Point, it would have minimum impact. Okay, because that habitat is disturbed all the time. If you did it on the inside Spurn Point, where it's an estuarine habitat, you'd find that fishing disturbance is very high relative to the amount of natural disturbance, and there's a kind of spectrum across there. So bear that in mind when you're considering how fisheries and the environment interact. So fishing effort varies spatially as well. So you get different levels of fishing effort in different parts of the North Sea. That's an old graph now. This goes back to, I think it goes up to 1990. But what it's showing is variations in fishing activity. You've got different gears here. So we've got seine nets in red. Other fish, that should be other instead of otter. I don't know what otter, or maybe with otter boards. So you've got trawling for fish here. You've got trawling for invertebrates in blue. There's not much of that in area 9. That's area 9 here. And then you've got beam trawl. And you can see different parts of the North Sea have been impacted to different scales by different fishing methods. So around in area 10 down here, you can see that beam trawls became really important. So this is Holland, this is the Wadden, and they have a big fishery for plaice in that part of the world. Here, what's this one? This is area 3. So area 3 is off the east coast of Scotland, and you can see that there's been a sort of gradual decline in fishing gears. The seine netting has declined quite a lot, and there's sort of trawling has maintained its activity. So invertebrate trawling. That invertebrate trawling will be for nephrops. I'll put some links up for information about fishing for nephrops or scampi. I edited a book on it, and I had a big project on it about 10 years ago. Well, that clock you can see behind me is actually a prawn, or an ephrops. So you can see here, now that's important because different fishing methods have different levels of impact. So a beam trawl has a strong impact on the seabed. The old fashions, especially when they were big, heavy wooden beams, and they would have a significant impact on the seabed. If you consider seine netting, then that's a much lower impact on the seabed in particular, because it's a bag basically that's put out and surrounds the fish. And as that's become less, it means there's less fishing effort using that method, but the relative change in impact will be less than if you reduce trawling. I think that's the point I want to get across here. So area 1 here, where trawling has vastly increased over time. This is the Fladden area, which we'll talk about a bit more in a minute. The Fladden area is an important prawn ground and whitefish, and you can see here that fishing trawl fishing has increased over time there. So there'll be much more impact of trawling in that part of the sea than there is down here. Sort of where it's been much less. So fishing varies spatially across the North Sea. It's not constant, and the methods used are different in different parts of the North Sea, and that's a reflection of what's available and of what fish is wanted by the market. And something we quite often forget is that the market is really important in fishing. This is an amazing animation that I made using some figures that I nicked out of a publication, and it basically shows how trawling for nephrops in the North Sea has increased over time. Okay, it became more and more significant. Well, it does it very. Oops, let's go back again. I want to run that again because it's so good. So there you go. So it's very constrained here. 60s and 70s, it gets more and more extensive. This is when we really started eating scampi in fish and chip shops. And then when you get as far as 1987, you can see, and then and in the late 90s, you can see that it was very extensive. So this is the Fladden area, a very important fishing ground. It's further offshore than most prawn areas. So these are really important prawn grounds here and down off the coast of, off the northeast coast of Scotland, Fraserburgh, Peterhead, and then down here just off Edinburgh. And there's also another one down here, it's not shown really, but off Teesside that became more important in later dates. These are mostly prosecuted by small boats. Up here, as the industry developed in Scotland and the boats got bigger, they were able to go out and prosecute a fishery that was much further offshore in much more dangerous waters. And the new nephrops boats that specialise in targeting prawns are really, really big boats. Not big, but very seaworthy boats that can tolerate just about any conditions. The Fladden ground's a bit different from other prawn grounds in that the prawns that are found there are big and they're well spread out. Now, they're big, that means they're worth lots of money individually. But because they're more spread out, you catch them at a lower density than you might do if you went to one of the inside grounds where the prawns tend to be smaller, but you get more of them. So small prawns are what ends up in your scampi that you eat in a pub. The big ones end up as langoustine in restaurants, So nephrops go from being pub grub to posh nosh. So you get them frozen stuff in packets, or you get them as sort of these big posh lobsters that are just as valuable, really, as lobster, like blue lobster. But the thing about Fladden grounds is they're spread out and they're big. So the fishermen only go there when they know they're going to get a good catch of lobster. Now, how do they know that? Well, the reason they know that is, hang on a minute. I've got to put a YouTube video on here. It's just technology. Ooh, what's that? No, don't want that. I want this. There you go. So this is a really exciting movie that we had made up when I had a project about nephrops, and you can see that. Hang on, not full screen. Is that it? Is that all I'm going to get? Okay, so you can see over time. So each of this is a boat that's fishing. So we defined a boat fishing by anything that's going more faster than 4 knots. And you can see how the pattern, the distribution of boats that are fishing changes over time. So here, you can see there's a concentration of boats in this part of the world here. This is in 2010, this is in the spring. And basically what happens is that these boats fish in packs. And you can see it's not just one boat on its own. So one boat from Fraserburgh will go out here, they'll find, and they'll do a bit of an experimental trawl, and they'll find some prawns, and they'll tell their mates. A lot of these boats are linked by families, you know. Or they're just good mates, and they'll help each other out if they think there's enough going around. But here, so this ground here, out here, boats have to spend a fair amount of money on fuel to get from Fraserburgh out into the middle of the North Sea, and then they've got to stay there for weeks. So they're not going to do it because it's no point just going out for a day. Now, they're not going to bother doing that unless you see that it's you're going to get a good catch, you know. And so this is how these guys fish. They fish in packs, and it suits the prawn fisher because there's about 20 different prawn grounds. If you look in the Ungfor's reference that I'll put up on canvas, you can see that they're managed in separate grounds, and they're called functional units. So Fladden is a functional unit. There's another one down here that's a functional unit. There's one on the west coast of Scotland, a functional unit. There's a Celtic Seas, another functional unit. And so these functional units switch on and switch off because prawns don't do the same thing all the time. At certain times of year, they're out more often and they're active and they're available to be caught. At other times of year, they just sit in their burrows. And they have this behaviour that's called a sort of crepuscular behaviour. So they come out when the light intensity is the light intensity that they prefer. So they kind of like dusk type intensity. So if they live in deep water, they'll come out once a day. And they might come out just for like in the middle of the day because that's when it's bright enough for them to come out. If they live in shallow water, they might come out twice a day. They'll come out in the morning, and then when it gets too bright, they go back inside again, and then they'll come out at dusk. And fishermen know that. So local fishermen know the best times to go and catch prawns. And so you get different patterns of behaviour in different places. Out in the Fladdens, out here in the Fladden, then it's quite deep, so they're probably only fishing sort of when it's certain times of day. I'm not sure when it is in this part of the world, but it's a fishery that basically manages itself because they only go there when the prawns are on and they're catching plenty of them and they're getting a good price. Otherwise, they'll go and fish one of these other grounds around here. Now, sometimes when fishing is poor here in their local grounds, all the boats that we're tracking here all come from Fraserburgh and Peterhead, okay? And you can see that they're not only fishing in Fraserburgh and Peterhead, and they started to spread out later in 2011. So here they're down off the Newcastle coast. This caused loads of ructions because the local fishermen fish here as well, and they did not appreciate these big Scottish boats that are very efficient coming down and fishing on what they consider to be their grounds. And you can see here also that they're spreading round the west coast. And into the Irish Sea. Now, those places all have their own fleets of boats. And again, this caused massive ructions at the time. And it's because these grounds were switching on at different times from the Fladden, so fishermen were targeting these areas more. But you can see it's very, very active. It's partly a reflection of the fact that the fleet increased in size as well over this time period. Like wasps, isn't it? You can see sort of angry wasps fishing in different grounds. But the point is that they fish in packs. That's the important point I'm trying to make. Okay, right. Let's get back onto PowerPoint, if it lets me. There we go. No, we don't want that one. Let me swap that over. You get these notes in your the notes have been uploaded, so you can read them yourself later on. So here's a sort of map of the distribution of fishing effort. This is with beam trawls across the North Sea, and it's concentrated off the sort of Danish and Dutch, Danish, German, Dutch coastlines, because they do a lot of beam trawling. Like I said, they're really interested in flatfish. The more intense the fishing, the darker the black blob. Now, I think the highest here. Yeah, it means it's fished this is 8 times a year. This square has been fished 8 times a year. It's not the whole square, it's just been fished 8 times a year. So it could be a bit of a misrepresentation of how much fishing is going on. On the right hand side here, we've got an example showing the marks that are left by trawls. And and what we're trying to show here is this is an area where the water is undisturbed. It's slightly deeper than the River Mersey, so I think it's about 12 meters or something. So here you can see the trawls have gone across the seabed. They've been fishing for whitefish and flatfish, and they've left a mark, and that mark's still visible a few days later. On the River Mersey, where there's more disturbance, you can see the marks don't show anymore. So that's the idea, that environmental disturbance can be as important as the disturbance caused by trawling. Okay, so it's not showing after a few days. So the habitat basically heads back towards normal.